Hello, I'm Dan Gibson, and in this video series we are examining the question, how did the early Muslims calculate the Qibla direction of their mosques? In the first video, we introduced the topic and we examined how the ancients could accurately draw lines on the ground that were within 1 degree of accuracy of the 4 cardinal directions, north, south, east, and west. In the second video, we discussed how we would fill in the rest of the chart, known to us today as the compass rose or the wind rose. This chart could be drawn on the ground with 32 points and within a degree of accuracy. In the second video, we learned that an Arab circle had 225 points or degrees. These were 32 aknam or directions, and these were broken down farther into zams. So 8 zams made an aknam and 32 zams made a complete circle, not 360 degrees. The Arabs had 224 degrees or zams in a circle. And I would like to encourage you to try and to think as an Arab navigator would and work with these 224 degrees. Now, if you've ever been on a road trip, you know that kids are always asking, "Are we there yet?" The Arabs are no different. They wanted to know how far it was from one place to another. Now, our architect has drawn the compass points on the ground, and now he needs to be able to measure distance. He might want to measure a few feet, he might want to measure several thousand feet, or he might want to measure several million feet. Measuring distance was a key to the ancient merchants being able to know where they were heading whenever they set out across the desert. They were traveling across the desert wastelands, and so they needed to know what direction, they needed to know how far they were going. These ancient merchants go all the way back into history. Nabatean merchants were traveling across the Middle East long before the time of Christ. You see, the deserts of Arabia separated the great civilizations. Egypt was on one side, Mesopotamia and Babylon were on the other side. Assyria was to the north and the desert between, and Yemen was on the south. And between them, vast plains of small pebbles and rocks, plus sand dunes on top that blew and moved across the desert. These merchants were the glue that held the Middle East together. They were the vital connection to the economies of these great empires. Plus, they were a means of communication between them. Goods cheaply available in one place were in demand across the desert. New discoveries in one civilization were wanted across the desert. And so these merchants needed to know where the target city was beyond the horizon across the desert. Trade routes were not roads laid out on the ground. Camel caravans used different routes, especially if there were hostilities between civilizations or if the local people wanted to tax them for crossing their land. So trade routes were constantly shifting, and the merchants wanted to be able to go a different route if something blocked their way. Navigators were constantly recalculating their routes as they headed for the unseen cities over the horizon. Later, mosque builders would use the same knowledge to allow them to orient their mosques so that the Qibla wall faced the Kaaba in the far-off holy city of Islam, which was over the horizon. So in this video, we're going to learn about how the Arabs measured distance. First of all, let's see what the Roman historian Pliny the Elder noted about the Arab merchants in his day. He was born around 24 AD, and so he was around during the time of the New Testament era and the establishment of the early church. However, in this case, we are not interested in Christian history, but in Arab history. And Pliny the Elder noted that the Arabs of his day counted their steps when they were traveling across the desert. I'm sure he thought it was rather strange, Pliny recorded that the trip from Timna, the capital of Qataban in Yemen, which was the source of frankincense, that trip from there all the way up to Gaza in the port city that was on the Mediterranean Sea was 2,437,500 steps, or 62 days by camel. So this was the distance that the incense caravans traveled when carrying incense from Yemen to the Mediterranean coast. Now, a step is different than a foot. A foot is short, but a step is longer. Arab men were about 5'5" tall, so there was about 1,000 steps in a kilometer. But the early Arabs did not have kilometers to measure. They were just counting steps. That is why they could tell Pliny the Elder that there were 2,437,500 steps on that particular caravan route. Now, once again, there was both a measurement on the ground as well as one in the sky. Steps were counted on the ground, but there was a way of measuring in the sky as well. When the caravans left Yemen, they traveled north to reach the Mediterranean. Centuries before this, the Arab merchants had noted that the North Star was relatively stable in the night sky. As they walked north, the North Star rose higher in the sky. If they would have made it to the North Pole, the North Star would have been directly above them. If they had been at the equator, the North Star would have been on the horizon or maybe just below it. So the Arab merchants began to measure the height of the North Star. Since the plains of Arabia were mostly flat, they could measure from the horizon to the North Star. In time, the Arabs learned to measure all of the 32 stars of the windrows, which we introduced in the last video. It was an excellent way of telling time as well as the height of the star. But that's a later lesson. Initially, they only calculated for the North Star. This measurement of the height of the stars was known as the science of Qiyas, the measurement of stars above the horizon. You can read extensively about this in Ibn Majid's book. This book has been translated, I've got it here, by J.R. Tibbets, and it's got the title, let me hold it back here so you can see it, the Arab Navigation in the Indian Ocean Before the Coming of the Portuguese. I have this book here, I've gone through it multiple times, and this book tells us how the early Arabs used both Isharat, which were local guides, as well as Majra, which were the celestial guides to navigate. Well, this book was not written until 1421. Ibn Majid, fortunately, gives us some clues of how the Arabs navigated back in more ancient times and how navigation developed up until his time. So, to determine distance north and south, a measurement was taken of the height of the North Pole. The width of a finger, which was Uzba, is used for a rough measurement. Like the Arab windrows, each Uzba was divided into 7 zams. Over the years, now I have tried various experiments measuring zams by hand, because they would hold the hand out and measure how far using how many fingers at an arm's length. Now, over the years, I've tried various experiments measuring zams, and I've tried to discover how it works, and it seems to me that it works for the average human being, no matter how tall or how short they are. When holding the hand at an arm's length, it's possible to measure the height of the North Star by placing one hand over the other and then deciding where on the final finger the North Pole star was located, thus measuring Uzba, which is the number of fingers, and Zams, which are 1/8 of a finger. Now, if they wanted a more accurate measurement, then the Uzba could be measured in the night sky. It was the width between 2 stars, El Ayuk, and which is there on the star, and the Deben was another star. It's there on the screen, and it's the distance. Now, the standard Uzba measurement was this bright star, and it was 4 Uzba, 4 fingers, 1, 2, 3, 4. over to the other star, which held at arm's length. So that 4 fingers were called a dhuban, and so one dhuban is made up of 4 isba, and 1 isba is made up of 8 zams. So they had these measurements. And it wasn't long before the Arabs began using small pieces of wood that had the dhuban, the 4, it had isba on it, it had zams, and there were various combinations marked out on the wood. The wood could then be held at arm's length to get a more accurate measurement. Ibn Majid quotes an ancient poem which says, "My instrument for qiyasi is 24 pieces of wood." So when the ancient Arab navigators considered north and south, his view of the world was measured in isba. No matter where he was in the northern hemisphere, he knew how far he was from north or south compared to other locations. The Arab navigators memorized the names of major cities and the isba, or the measurement associated with that city. Now, according to this map, which is not very accurate, Gaza was at 17 isba, 5 zams. Jerusalem was at 17 isba, 6.5 zams. Petra was at 17 isba. Najran in Yemen was only 8 isba and 0.2 zams. Now, let's look at some actual maps. I have some here, and I have lots of maps drawn, and these maps are in isba, not in Western degrees. So there are different maps with the isba on them. Here's the Red Sea and the Gulf of Aden. I don't know if you can see that very well, and all the different isba down the side. I have a chart of the Arabian Sea here, and it gives all the different isba and the directions. Here's the east coast of Africa in isba again, and down the side in zams. Here is the Indian Ocean, and you can see here the entire Indian Ocean, and all marked out the names of the cities, and you can figure out the zams. Here's India and the Bay of Bengal. The Bay of Bengal was particularly important. You can see down here in the south around Sri Lanka. That was the place where the ships all came. And here's one. It has southern India, and also over here we have the Southeast Asia and the different places, and all the isba marked on the map. Originally, the Nabateans memorized the names of the cities, they knew those, and the isba associated with each of the trading centers that they had across the Middle East as far as India and each place, so they knew where and how far north or south those cities were. In time, the Nabateans ventured as far as India, and so isba numbers were memorized for the major centers in India, especially the ports that were there. The first record we have of Arabs traveling to China was between 25 and 55 AD. At this time, a Chinese envoy visited the Middle East, and on his return to China, he brought skilled Arabs back from the Nabatean court back to China, along with all kinds of other paraphernalia that he had picked up. The Chinese noted that among these skilled Arabs there were, let me quote from the Chinese history, there were musicians and some skillful jugglers who performed transformations. They belched fire, they changed the head of an ox to that of a horse, they amputated limbs and they replaced them. They also knew how to play with little balls to keep as many as 10 in the air at a time. Now, I'm sure these jugglers and magicians were fascinating, but no doubt among the skilled Arabs were astronomers and navigators. If nothing else, the average Nabatean Arab merchants would have known how to measure the isba of the Chinese cities they visited. Is it any wonder that Arabs soon after this began seeking out both land routes and maritime routes between Arabia and China? An annotated translation of the Chinese record called the Weilu is being carried out. It's been done by John E. Hill, and he has worked on this project, and I have had regular communication with him over the years as he has compared the Chinese records to the geography of the Middle East. This record now of this visit comes from the chapter on the Western regions taken from Hao Han Shu 88, the official history of the later or Eastern Han dynasty, which was from 25 to 221 CE, which was completed by Fan Yi, who died in 455. Fan Yi used a number of earlier sources which haven't survived. So the particular chapter of interest tells us about from the years 25 to 55 AD, when the Nabateans were in China for the very first time. In time, the Arabs developed a number of simple instruments for measuring the height of the stars. The most common was called the camel, a small rectangular of wood with a string in the middle. The string had knots in it for various stars. It allowed quick measurement for the height of stars. Some camels were large enough that they could measure 4 or 8 or even 12 uzba down one side of them. The Arabs also developed a quadrant. Some were a quarter circle and some were a half circle. The navigator would aim the flat edge at the star, and then a string with a weight at the bottom would accurately indicate the isba and the zams. He no longer needed a horizon. Now, it didn't take long for the Arab navigators to figure out that if one traveled 168,000 steps northward, it would raise the North Star 1 zam. Since a caravan moved at around 40,000 steps a day, it would take over 4 days of traveling to raise the North Star 1 zam. Now, I would like to deal with a question that often comes up when I'm talking about this, and people ask, how did the ancient Arabs keep track of the steps while they were traveling? I remember walking with my sons some years ago in the Arabian desert trying to count out our steps. We always had difficulty because it's easy to become confused with your numbers. Where was I at? The Arab solution was brilliant. They didn't count steps. Rather, they recited poetry. Poetry had rhythm, and it aided in the marching of the caravan. The men walked on the ground, the camels carried goods. In Europe, in the Middle East, they used a drum. When you heard what was called the walking drum, you knew a caravan was near. Boom, boom, boom. Or an army was near. Armies used drums as well. The Scottish used drums and bagpipes for marching. But the Arabs used poetry with a distinct marching beat. As they walked along, someone would begin to recite a long poem. Others would take it up, and sometimes everyone would be repeating it together. And so the Arabs became known for their long poems. Each poem had a number attached to it. In fact, the earliest Arabs didn't use numbers, they used the letters of the alphabet. This goes back to pre-Islamic time and to the use of Nabatean letters as numbers. And so these numbers told them how many beats were in the poem, and so they could start the poem and they would know at the end how many steps they went. Now, for some non-Arabs, it seemed pretty obscure, these letters or numbers stuck on the front of poems. Some even thought they were magic numbers. Now, only a handful of the earliest poems survive to this day. Most of the poems were lost along the way, or later people who recorded them just turned them into stories, and the rhythm of the caravan was lost. In fact, when these Arab stories were translated into English, the translators were totally unaware of the importance of the rhythm. Back in the 1700s and the 1800s, it was common for Europeans to refer to the singing caravans of the Arabs. To the Western mind, the chanting caravans were just singing. Europeans were interested in translating these stories. What did they say? And the poems, and what were they? And they missed out the rhythm that was there. Even today, most of the Arabs who are learning these ancient stories have lost that rhythm that they originally had in the desert. With the coming of Islam, major changes came to the Middle East. One of these changes was that the Arabs moved out of the desert and began to invade lands previously held by the Roman Empire. In the Roman Empire, there were roads, which were marked with milestones. The Arab armies no longer needed navigators to lead them across the deserts. And so, by the time of Muhammad, around 600 AD, the use of desert navigation was quickly coming to an end. Goods were being transported from Yemen north to Roman lands on boats. Dhows, not camels, carried goods. Desert navigators were not needed. Land routes were well laid out by this time. Sea navigators were needed, and the chanting of poetry made no sense on the seas. Other methods for navigations had to be developed by the Arabs to enable them to cross oceans of water and arrive exactly at the port they desired. But up until the time of Muhammad, poetry remained an important part of desert navigation. It was during Muhammad's lifetime and right afterwards that poetry began to lose out its role in navigation. Now, much of our knowledge of early Arabic poetry comes from Al-Farahidi. He lived over 100 years after the use of poetry for navigation fell out of use. Al-Farahidi wrote an early dictionary of the Arabic language in 8 volumes. He also collected samples of 15 scales of poetry known in his day, and he compared them with the Quran. Because the day of the camel caravans and the navigation by stars had long passed, Farahidi called the meter of the poem the wazn, or the weight, or the scale, rather than the earlier form of tafila. He also called each line a bait, or a house, which could be divided into sections called shatar, or half lines. So Al-Farahidi classified poetry into 15 types on their wazn, or weight. This is a more modern interpretation of poetry, and it overshadowed the importance of the ancient beat, or darba, the measure, the tafila, which was so important to the early navigators. Unfortunately for us, Al-Farahidi's treatise on poetry came over 100 years after the revelation of the Quran, and by this time poetry had developed into its own art form and was no longer a part of navigation. In Farahidi's time, armies, not camel caravans, marched across the world from city to city along well-marked roads, many of them designed to move Roman armies quickly to the edge of the empire. But by this time, the armies of Rome were retreating from the frontiers, and the Muslim armies were now using these same well-marked roads to pierce deep within the Roman Empire. Now let's go back to Pliny the Elder. He was told that it took 2,437,500 steps to walk from Timna, the capital in Qataban, all the way up to Gaza. And that's 14 uzba, and 3.4 zams if you're measuring in the stars. So when the young Arab kids would ask, "Are we there yet?" the parents could answer, "I don't know. You check the stars and tell us." Well, our time is running out, and we still have not learned everything that the Arabs knew about navigation. So in the next video, I will try and bring some of this all together for us. I'm Dan Gibson, and this has been the 3rd video in the series about early Arab navigation.